Welcome to this video, ladies and gentlemen. It's PVS the tutor. I'm back with another question. This question actually came in the 2023 GCE paper 1, and this was question B2. In fact, this was section B. And let's see how we can answer this question. The question says, figure B2.1, it shows the same cone being placed in three different positions, position X, Y, and Z here on a flat surface. So it's the same cone, by the way. That means that's one of the things that has to be kept constant. Here we have tip of the cone resting on the surface. That's a tip there. Here we have cone laying on the surface. So that is the surface. That is the cone's surface. Base of the cone resting on the surface. So this base here is on the surface there. Now, define center of mass. Okay, define center of mass. Now, the center of mass is a point. So this is a point, okay, within an object. Within an object where the mass of an object is concentrated. So what does this mean? This center of mass thing. Now, what this means is that at this particular point within this object, all right, the object would balance perfectly if it is supported only at that particular point. All right, so if we support the body or that object at that particular point, it will balance perfectly. That's the center of mass. Identify the cone in a neutral position. Now we have three types of equilibrium. We have stable, unstable, and neutral. Now, which one is stable? Okay, this one here is stable. And this one here is unstable. But this one here is neutral. All right, so under stable, when you tilt an object, all right, it will bend, but it will go back to its original position. Get the concept, eh? But for unstable, when you tilt it from one side, it won't go back to its original position, but it will instead maybe fall off, or like that. It will lose balance. Then in the neutral, there is no tilting. You can't tilt something in the neutral position when something is in a neutral equilibrium. You can't tilt it. All right? It means you can just maybe move it in such a way that it flows like that, or it rolls like that. All right? So the cone, which is in a neutral, is the Y. It's the cone Y. Okay? It's the cone in position Y. So we can say the cone in position. The cone in position what? In position Y. The reason is simple. In case I ask you to give a reason, the reason is that for this cone, the way it is like this, right? Because it is lying where on the surface. All right. It means when you try to tilt it, okay, slightly, just slightly, you discover that it remains in its new position without returning to its original orientation or its original position. So when you try to tilt it, it won't do anything. Instead, it will just remain in the same position. But for stable, when you tilt it, maybe kakoni kazanyamuka like that, then again it comes back to its original position. But for unstable, when you try to, let's say, to push this cone this side, it will fall off this side. This is for unstable. I think I hope I've explained. Then state two factors that affect the stability of an object. Now there are quite a number of factors that affect the stability. The first one I'm going to mention is the base area. Okay. Now with the base area is that when the base area is larger, usually you are going to have an increased stability. It's simple as that. All right. Now, why is it so? Why is it that when you have a larger base area, you have an increased stability? This is because when you have a larger base area, it means your base is wider, which provides a larger support. And this will make it very hard for an object to tip over like that. Then the next one is the height of the center of mass. The height of the center of mass. Now this is one of the topics which most people skip when teaching, but it's really important that you do it, whether you've been taught or not. Okay, this is stability. Now, what do we mean by the height of the center of mass? Now, when the height of center of mass is lower to the ground, this means that object will be in a very, very stable situation. I'll give an example of those, you know those let's say Lamborghini, right? They are very closer to the ground, such that certain amps, they can't even pass through. Those cars are very stable as compared to a tractor with a big, which is, let's say 1 meter up from the from the road, like that. Basically, okay, let me just draw like this. So assume this is a car, this is a ground, right? This is a car here, and this is a car. So we have a car of this nature. Then you also have got this car, which is like this, okay, of this nature. Which car is stable between car A and car B? You discover that car A is more stable than B. Reason being is that the height of the center of mass for this one is lower as compared to the height of this one, which is what? Higher. So the height of the center of mass for this one is higher, hence it's less stable. Okay, this one has got a lower the height of the center of mass, so it is more stable. This is what we're trying to explain when there's the height of the center of mass. Ladies and gentlemen, I hope with a few words which I've exhausted here, I hope that you've learned one or two things, and you can join me in my online classes at a very affordable price. Physics, science, chemistry, I'm available, even in mathematics and biology. Come to the best online tutor if you want to learn more. You are welcome.